Hello everyone. In this topic of coordinate geometry, let's understand how can we find the distance between parallel lines. So let's get started. First of all, what we will do is that we will draw a grid. So I'm drawing a y-axis, I'm drawing an x-axis, and then let me draw a line. This is not drawn to scale, keep that in mind. Let me draw a line y is equals to x plus 3. So this is a line that's going like this, and this line is y is equals to x plus 3. Let me draw another line, and before that let me just push this down, and now let me draw another line which is y equals to x minus 3. So there is an orange line. Let me label this as L1. The equation of L1 is y is equals to x plus 3. And then there is the blue line that I'm labeling as L2. L2 is y is equals to x minus 3. That means I can mark this point as A. This is 0, 3. I'll now mark this point as B, which is 0, negative 3. So I need to find the perpendicular distance between these two lines. These two lines are parallel. They have the same gradient. Now, what is the approach? What I'll do is that I'll start from this point and let me draw a dotted line towards the blue line, and this angle is 90 degrees, and let me mark this point as C. So now the very first thing is gradient of line 1 and gradient of line 2 is the same. They are parallel. They have the same gradient 1. Double check. Y is equals to mx plus c. Y is equals to mx plus c. The coefficient of x is 1. The coefficient of x is 1, and that is the slope. Now what about equation of the line which I have labeled as AC? That should be the negative reciprocal of gradient of line 1 or gradient of line 2. They are the same, which is negative 1 over 1, which comes out to be negative 1. Now what we can do is that we can take the point A, which is 0, 3. We have the gradient of this line AC, which is negative 1. And let me write down the equation. Y is equals to mx plus c. So the gradient is negative 1. The y-intercept is 3. Therefore, the equation is y is equals to negative x plus 3. That is the equation of this green line, which I have labeled as AC. Now, understand the scenario. We have this line, which is AC. It's going like this. We have the line B or the line L2. They are intersecting at the point C. That means if I'm able to find the coordinates of C, I can find the distance AC, and that is the perpendicular distance between parallel lines. So now we have the green line, that is AC. So let me write AC over here. That is y is equals to minus x plus 3. And then we have the line L2, which is y is equals to x minus 3. Now solve simultaneously two linear equations in two unknowns, and we will find the coordinates of C. So very simple working. Y is equals to minus x plus 3. Y is equals to x minus 3. We will use substitution. Negative x plus 3 equals to y. Positive x minus 3 equals to y. In other words, negative x plus 3 equals to x minus 3. Negative x equals to negative 3, negative 3. Negative 2x is equals to negative 6. Make x the subject. That comes out to be 3. So the x coordinate of C is 3. Plug in any equation. Y is equals to x minus 3. Y is equals to 3 minus 3. This comes out to be 0. Therefore, the coordinate of C is 3, 0. Now let's look up at the diagram. First of all, the diagram is not drawn to scale, and it's very close to the original thing. That means somewhere here there should be the point of intersection that should be on the x-axis. So calculations, that is supreme. Calculations won't go wrong unless you go wrong. Diagrams are approximate. Diagrams are not misleading, but they're not drawn to scale. That is why in such questions they say very specifically, find by calculation. So now we have found by calculation the coordinate of C. We already know the coordinates of A, which is 0, 3. That means if I find the distance AC, that is the distance between A and C, that is the perpendicular distance between parallel lines. So let's get started. We have 3, 0, we have 0, 3, and AC, that is equals to 3 minus 0 whole square, 0 minus 3 whole square, square root. Let's do a bit of working. This is 9, this is 9, this is square root. That is 18 square root. I can even write this thing as 9 into 2. Square root, that is root 9 root 2. Root 9 is 3. Root 2 remains as it is. This is the simplified answer in the exact form. So that is the strategy of finding the distance between parallel lines. Let me recap it for you. So I'm just drawing a y-axis. I'm drawing the x-axis. And there was this line, just a rough sketch again. Then there was the other line, the orange one. And the green line was the line from here to here. Again, it's not drawn to scale. This is L1, this is L2, this was the point A, this was the point B, this is 90-degree angle, this is C. So the objective is finding the magnitude of C. In order to find magnitude of C, we need coordinates of C, which is unknown. In order to find coordinates of C, we have to solve simultaneous equations. Which two equations? The green line, which is AC, with the blue line, which is L2. The equation of L2 is given. So all our effort were focused on finding equation of C. The y-intercept was 0, 3 in this case. And the gradient of AC was the negative reciprocal of either gradient of line 1 or negative reciprocal of gradient of line 2. Why? Because these two gradients were exactly the same. So now backtrack. We have A. We find the gradient of AC. We find the equation of line AC. We solve it simultaneously with line 2. We find the coordinates of C. And based upon that, we find the magnitude AC, the distance between A and C, the length of line segment AC. So that is how this question is completed.